Section 8.3, Part 2. Identifying parts of linear functions from verbal descriptions. Josie has 1.5 cups of water in her watering can. She can fill the can before watering her plants. Water flows into the watering can at a rate of 1 cup every 4 seconds. So I'm going to read this again. Josie has 1.5 cups of water in her watering can. That was where she started. She fills the can before watering her plants. Water flows into the watering can at a rate of 1 cup every 4 seconds. The graph represents the function described in words. You see her initial value, where she had 1.5 cups of water in her watering can. That's her initial value. That's where the graph will touch the y-axis. Look at my graph touching the y-axis right there at 1.5. That's at 1.5. So the name of that point is 0, 1.5. That's the initial value. You see this line is going upward with a positive slope. The horizontal axis is time in seconds. The vertical axis is the water in cups. So we started out with 1.5 cups of water. And then she fills the can before watering her plants, and the water flows into the watering can at a rate of 1 cup every 4 seconds. Write each value or equation for the linear function. Find the rate of change of the function, the slope of the function, the y-intercept of the line we've already talked about, the initial value of the function. Well, the y-intercept is 0, 1.5. The initial value would be 1.5. The function rule will be the equation. We've got to determine the slope. What is the slope? What is the rate of change? The first thing that I'm going to do to find my slope is I've got to determine my rise and my run. Now, I could use this exact point, but let's look and see if there's another perfect point where the line passes through the exact corner of the graphing paper. I see a point. This one's perfect. It passes through 10, 4. So I've got a point 10, 4 on the graph. Let's see if I can see another perfect point. There's another perfect point. 18, 6. That's another perfect point. Another perfect point would be 26, this point, 26, 8. I'm going to use these points to determine my rise and my run instead of using the ones with decimals. That's harder to determine the slope. So from this point to this point, what would I have to rise and what would I have to run? I would need to rise 1, and I would need to run 1, 2, 3, 4. And I'm going to do that again just to double check and make sure that I have counted my slope correctly. To go from this point to this point, my slope should still be 1/4, or 1 and 4. 1, rising 1, running 4. So rise over run. My rise is 1, my run is 4. They're both in the positive. My line is slanting upward. So the rate of change of this function would be 1/4. The slope of this line would be 1/4. So if I was to write the equation of this line in the form of y equals mx plus b, I know my slope or my rate of change is 1/4. I'm going to substitute that in for m, 1/4 x plus, what is b? What is the output when the input is 0? Well, the point that I have that represents my y-intercept is 0, 1.5. That's 0, comma b. b is 1.5. So your rate of change is 1/4. Your b, which is your initial value, is 1.5. Therefore, your function rule is y equals to 1/4 x plus 1.5.